The next section we're covering is on permutations and combinations. So what we're going to do is go a little bit deeper into our counting techniques. Again, if we roll 2 die, pretty simple. The first die has 6 options, the second die has 6 options. 6 times 6 would be 36 total outcomes. What if it gets a little more complicated? And that's what this section is about right here. 12.2 Permutations and Combinations. I want you to write 2 words under here. Permutations, I want you to write order matters. And under combinations, I want you to write order does not matter. Very, very important for you to write and understand these 2 different things. When you have permutation, order matters. When you have combinations, order does not matter. Let me give you an example. If I wanted to rank the 3 best students in the class, it would matter if you got first place or second place in that ranking to you. Versus, what if I wanted to take 3 of you out to lunch? If I took 3 of you out to lunch, it doesn't matter if you were picked first or picked second, you're still coming out to lunch with me. Even though we can't go out to lunch with the current coronavirus, but just roll with me, okay? So permutations would be like ranking the top 3 students. Combinations would be like imaginarily taking 3 of you out to lunch. Nice word I just made up there. Okay, so let's read this. Factorial. Suppose 4 different colored squares are arranged in a row. One possibility would be the following. I'm just going to call it red, green, yellow, and blue. How many different ways are there to order the colors? Well, there are 4 choices for the first square. Think about, we have 4 places. We have first, second, third, and fourth. First, second, third, and fourth. And what options would I have? Well, I'd have 4 options, 4 different colors that I could put in the first. That would leave me with 3 different color options for the second because there's no repetition, 2 for the third, and 1 for that. The fundamental counting principle said you would multiply that out, which would give you 24 different possible options of arranging these 4, presuming that order matters. This product, 4, 3, 2, 1, is called a factorial. So, what is a factorial? Look at this notation right here. In factorial, when you look at the notation, is actually an English exclamation mark. You don't read it like in with emphasis like you would in English. You would read this as in factorial. What does in factorial mean? Whatever the number n is, for instance, in this example, we had 4 factorial. Let me go to the pencil, 1 second. 4 factorial. Anytime you have n factorial or a number factorial, you start with that number, and then you're going to multiply, decreasing each value by 1 all the way until you get to the number 1. So it shows you 5 factorial would be 5, 4, 3, 2, 1, 8 factorial, 8 on down, 1 factorial would just be the number 1 itself. So that is factorial notation. Why do we care about factorial notation? Because it becomes a lot easier to put into our calculator if we learn this factorial notation. Just a little note right here, 0 factorial by definition. How many ways can you arrange 0 objects? The answer is 1. You don't arrange them at all. So n factorial would be the way to arrange indistinct objects. One thing that you can notice when you're trying to evaluate factorials, for instance, 10 factorial is 10 times 9 times 8 all the way down to 1, which is also the exact same thing as 10 times 9 factorial. Which is the same thing as 10 times 9 times 8 factorial, or 10 times 9 times 8 times 7 factorial. This can help us when we're trying to simplify factorial notation when we have large numbers that our calculator can't handle. I'll give you an example of that in just a minute. But right now, let's use that TI-30XS, our class calculator, to enter factorial notation. You'll notice on the calculator there's a PRB button. Once you hit the PRB button, you'll see if you hit the number 3, or you could go down and hit enter, you're going to be able to use the factorial. So for instance, how would I do 5 factorial using my calculator? Well, I don't have to type 5 times 4 times 3 times 2 times 1. What I could do is hit the number 5, hit the PRB button, either scroll down and hit enter, or just hit the number 3 and then enter. My screen should look like this, where I have a 5 factorial, and then it'll tell me what the answer is. So using your calculator, you should be able to do every single one of these problems. For instance, 5 factorial minus 3 factorial should be according to my calculator, I'm getting the number 114. 5 factorial minus 3 factorial. 9 factorial over 6 factorial, if I put that in my calculator, I get 504. As a brief exercise, it's not in the notes, but I want you guys to go back to something that I said earlier. Try putting this, I'm going to put part C here, 102 factorial over 100 factorial into your calculator. Take a moment and do that now. If you tried putting it into your calculator, what you should see is that you're getting an error. The error is because these numbers are far too large for our calculator to simplify. Our calculator actually tries to calculate 102 factorial, which would be 102 times 101 times 100 all the way down. That's too big of a number for our calculator to store, even using exponential or scientific notation. So, what you can do is go to the previous definition of a factorial, realizing that 102 factorial is really 102 times 101 times 100 factorial, 100 all the way down. All the way over, we have 100 factorial on the bottom. Because of this, we're able to simplify the 100 factorials, because that's 100 times 99 all the way down. Every single one of those numbers would simplify, and we could be simply left with 102 times 101, plug that into our calculator and get the answer. So if you're ever putting a factorial into your calculator and you get an error on overflow, one way of doing it is by expanding it out and seeing if you can make the factorial smaller before you plug it into your calculator. Continue with example 2, plugging these directly into your calculator. 7 factorial plus 4 factorial in my calculator. Again, I'm hitting that PRB, scrolling down or hitting the number 3, and then enter with the factorial symbol. I'm getting a total of 5,064. When I put 8 factorial over 4 factorial, I could expand this out, but these are small enough numbers to just straight put it into my calculator. I'm getting 1,680. So, let's move on from factorials to permutations. What's the difference between factorials and permutations? Well, quite honestly, they're the same thing. There's just one slight difference depending on what it is. First thing I want you to do, once again, with permutations is write order matters. This is the example where I said, what if I wanted to rank the top 3 of you in the class? That is a permutation because the order would matter. Versus, again, what if I wanted to take 3 of you out to lunch? That would be order does not matter. You'd be coming to lunch whether you were picked first or second. So permutations are going to be used when order matters. That's the most important thing you know about permutations.